The fundamental process for running programs in the Wolfram language is evaluation, which mostly consists of applying rules that replace one expression with another. For example, evaluation of range of 3, 6 applies a built-in rule that replaces that input with the list 3, 4, 5, 6. New evaluation rules can be added using assignments. For example, the assignment z equal 9 creates a rule that replaces z by 9 whenever z is encountered during evaluation. Assignments can also be used for defining functions. For example, entering an assignment for f of p underscore creates a rule that is used whenever an expression that matches the pattern f of p underscore is encountered during evaluation. All of the rules that are used during evaluation are associated with or attached to symbols. The rule for evaluating range of 3, 6, for example, is attached to the symbol range. The assignment z equals 9 attaches a rule to the symbol z, and the definition that was just entered for f of p underscore is attached to the symbol f. For definitions that were entered using assignments, evaluating question mark followed by the name of the symbol gives a display that includes the evaluation rules that are attached to that symbol. For example, this gives information about the symbol f, including the evaluation rule that was created by the assignment to f of p underscore. After an evaluation rule is applied, the system looks for rules that apply to the new result and repeats that process until there are no more applicable rules. For example, entering a rule to replace x1 with x2, and a rule to replace x2 with x3, and a rule to replace x3 with 99, and then evaluating x1 results in all three of those evaluation rules being used in the evaluation of x1 to end up with 99. This way of doing evaluation is sometimes called infinite evaluation, since the process could in principle go on forever, but usually it ends after a few steps. For example, here's an assignment that defines a function g of n in terms of g of n minus 1, and a second assignment that defines a value for g of 1. And here's an evaluation that uses those rules and a result from the trace function that shows some of the expressions that came up during that evaluation. Evaluating g of 10 applies the rule for g of n to get a result involving g of 9. The same rule is applied to g of 9 to get a result involving g of 8, and so on, until the rule for g of 1 is applied, and then everything is multiplied together to get the final result. These rules for g are just a recursive way of calculating 2 to the n, so the result from g of 10 can also be obtained by evaluating 2 to the 10th. When evaluating an expression that has elements, the standard order of evaluation is to evaluate the elements before looking for rules that apply to the enclosing expression. For example, in evaluating this input, range of 3, 6 evaluates to the list 3, 4, 5, 6, and the enclosing partition function is then applied to partition that list into sublists with 2 elements each. The result is the same as applying partition to the list 3, 4, 5, 6. It is possible to prevent evaluation of the element range 3, 6 in that example by enclosing that element in unevaluated, but that gives a very different result. Instead of partitioning the list 3, 4, 5, 6, the partition function then partitions the unevaluated expression range 3, 6, which results in an intermediate result of range of 3, 6, which gives that different result. The point here is not the details of what happened in that specific example, but that order of evaluation is important, and the standard order is to evaluate the elements of an expression before evaluating the expression. Although standard order evaluation is the default, there are many common exceptions where non-standard order is essential to the purpose of the enclosing function. For example, the purpose of the do function is to evaluate the first argument for various values of the iteration variable, but this can only work if that first argument is held unevaluated until after values of the iteration variable are assigned. It is possible to force evaluation of that first argument by enclosing it in evaluate, which in this example causes that first argument to be evaluated before the enclosing do function sees it, and subsequent evaluation of the enclosing do function produces no output at all. Holding of elements unevaluated in functions like do is controlled by attributes, which, like evaluation rules, are properties of symbols. The symbol do, for example, has the attribute HoldAll, which causes all of the elements in do to be held unevaluated. HoldAll is one of several attributes that result in non-standard evaluation. 3 other attributes that affect evaluation are flat, listable, and orderless. For example, setting the flat attribute for a symbol h causes elements with head h to be spliced into an enclosing expression with head h. Setting the listable attribute for h causes h to be threaded over lists, And setting the orderless attribute for H causes elements in an expression with head H to be sorted. The flat and orderless attributes have other effects as well, most notably in pattern matching, but these are the effects that happen as part of evaluation. Additional information on evaluation can be found in the Wolfram documentation in the tech note on evaluation, which summarizes all of these details. Within this tech note is a short summary of all of the steps in the standard evaluation sequence. The process starts with evaluating the head and the elements of an expression, subject to the effects of evaluate and unevaluated, and the effects of various attributes, like the HoldAll attribute that came up in the examples. Evaluation of elements before evaluation of the enclosing expression is referred to in the documentation as standard evaluation, and exceptions where elements are held unevaluated is referred to as non-standard evaluation. After that step, any effects of the flat, listable, and orderless attributes are applied, and finally evaluation rules are applied, including rules that have been defined using assignments and built-in rules. As an alternative to this tech note, there is a more tutorial tech note on evaluation of expressions that covers much of the same information.